Hello everyone, welcome to my channel. So I am left with the last part of bonding, that is coordinate bonding. So today I will finish with that part and we will be done with bonding. Okay. So without further ado, let's get started with the video. Okay. The definition of coordinate bonding is that it's a special type of covalent bond in which both the electrons come from the same atom. So first of all, it's a covalent bond only. Okay. Means covalent bond means again the mutual sharing part, which will be there in this case as well. But the electrons will be provided by a single atom. In a covalent bond, we have got two atoms in which mutual sharing happens. Now in this case, both the electrons will be donated by a single atom. Only one is going to involve itself and give away both the electrons. Okay. Example, NH4 plus, H3O plus. Soon I will be showing you the formation of bonding in this case. For now, at least know the example, NH4 plus, hydronium ion and ammonium ion. These two are the ones present in ICSE syllabus at least. Yes, so see, ammonium ion. First, ammonia. How is ammonia formed? NH3. NH3 is formed by mutual sharing of electrons between nitrogen. Nitrogen has got 5 electrons in the outermost shell. 1, 2, 3, 4, 5. And one hydrogen in each side. Hydrogen and nitrogen will make a bond like this, right? So this is my ammonia molecule. Ammonia is formed. Just this is a revision. I have already shown you how ammonia is formed and all. Ammonium ion. Ammonium ion NH4 plus is basically formed by combination of NH3 and H plus. Okay. Now see, NH3. In NH3 what we have? I'm not showing NH3 separately again. NH3 what we have is this electron present vacant. These electrons are known as lone pair of electrons. Lone pair of electrons. What are lone pair of electrons? Lone pair of electrons. The electrons which do not participate in any kind of bonding, which do not participate in any kind of bonding. So they are not involved in bonding, right? Any kind of bonding is known as lone pair of electron. How many lone pair present in ammonia? 1. Pair. See, I'll consider the pair, not 2 electrons. Yeah, right. A lone pair contains 2 electrons. One lone pair is equivalent to 2 electrons. But how many pair is present? Only 1 pair. Fine. Now these electrons are alone. They can easily be donated to one H plus, which is having no electron. It needs 2 electrons to satisfy at least the first shell. First shell needs 2 electrons. These 2 electrons will be donated and that's it. This is how NH4 plus is going to be formed. You just need to show the lone pair of electrons from ammonia, from the nitrogen atom of ammonia to be donated to H plus, and NH4 plus is formed. That's it. So this is NH4 plus. Similarly, H3O plus, hydronium ion. Hydronium ion is H3O plus. How is it formed? Between water and H plus. Before that, just a recap. Oxygen has got 6 electrons in the outermost shell. 2, 6. So 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Now it needs 2 more electrons. So hydrogen, 1, another hydrogen. So bond with hydrogen and hydrogen means these 2 bonds will be formed. The purpose of this is that I can show you how many lone pair. Here there will be 2 lone pair of electrons. 2 lone pair is equivalent to how many electrons? 4 electrons. Okay. Now 2 electrons left. In this condition, water can donate 1 electron to H plus, leading to formation of H3O plus. So 1 lone pair of electrons will be donated to H plus. That's it. So this is your hydronium ion. Hydronium ion. So these are the 2 important examples that come in class 10, and this is enough for your syllabus. So this is all about covalent bonding, coordinate covalent bonding. Some books they have written it as coordinate covalent bonding only because it's a special type of covalent bond in which lone pairs are only given. No charge formation, no ion formation, so not ionic, but a type of covalent bond. Okay, one more thing is important, polar covalent bond and non-polar covalent bond. This part I have not said. So check this out. Compounds are said to be polar when shared pair of electrons are equally distributed between two atoms. Unequally distributed between two atoms. See, if for example, if I consider HCl, if anyone who have the idea of electronegativity. See, electronegativity means if among these two elements, one is having the tendency to pull the electron towards itself, then it is known as a polar compound or polar covalent compound. Chlorine is more electronegative. So more electronegative. Electronegative means the tendency to accept the electron towards itself. Someone will keep the electron towards itself, someone will give away the electron. So hydrogen is the one who is not having that much tendency to accept electrons. So it will be more electronegative is chlorine, hydrogen is comparatively less. So in this case, the electrons are going to be unequally distributed. Like this, if I show HCl like this, so I can show it as H is having electron pair less and chlorine is having electron pair like this. This is the condition in which I can call this as polar compound. So polar can be represented as H plus and Cl delta minus. So this is your polar covalent compound. Okay, so polar covalent compound is the one in which the shared pair of electrons are placed or present towards a particular side. It is taking a particular side. But in case of non-polar covalent compound, no such side will be there. So they are going to be equally distributed. The easiest example among these are, just a second, yes, the equally distributed. So example is H2. Easiest example, H2Cl2. Why? Because both the atoms are similar. So both will be having equal tendency of pulling the electrons. If you have affinity or negativity, electronegativity means basically the tendency to accept electron, or affinity means the love for the electron. So hydrogen is, both the atoms are similar, so both will be having equal tendency. Chlorine, both the atoms are similar, Cl2, N2, anything in which you have got the same atom will be non-polar for sure. Just close your eyes and write down non-polar, that's it. The second example is charge separation will take place in this case. Charge separation means one is having plus, already I have shown. Plus means I don't need electron, let the electron go, so it's plus. And no charge separation, yes, both are pulling them equally. This hydrogen, whatever pull is there from its side, the other hydrogen, obviously same atom, will have the equal pull. So it is no charge separation will take place. In this case, the overall charge separation is 0. In this case, obviously there is some charge separation. Okay, this is it. Next, if you have to do, next important is the question answers. See, application part is comparatively different than the theory part. This is the basic theory. Now see the questions. I'll also try to solve some questions and I'll show to you so that it becomes easier for you. So that is it for this video, and I'll be coming up very soon with some new chapter. Till then, thank you. Bye bye.